So here's the day 14 review answer key. Let's start with number 1. It says factor each or the following polynomials to determine the zeros. So we're going to factor this one. We're going to look at what multiplies up to 12. So we've got 1 and 12, 2 and 6, and 3 and 4. So we want to multiply up to positive 12, but add to negative 7. So that means we're going to have negative 3 and negative 4. So those are going to be our factors, and then it says find the zeros. So that means we're going to figure out when do each of these equal 0. So we set them each equal to 0 and solve. Add 3 to both sides, we get x equals 3. Add 4 to both sides on this one, and we get x equals 4. All right, let's look at number 2. Also factor this one, so 5x squared, to get 5x squared, it's going to be 5x and x. And then to get negative 6, we've got a couple options. We can do 1 and 6 or 2 and 3. And so 1 and 6 add up to 7, but the problem is, like if we put a 1 here, that's going to be 5 times 1, which would be 5x. And a 6 here, that would be 6x. That's not going to give us 7x when we add those together. So if we switch the 6 and 1 around, that's not going to work either. So let's try 2 and 3. This would be, let's see, if we put a 2 here and a 3 here, that would be 10x and 3x. And so if we have positive 10 and negative 3, then that will give us positive 7x. So to get positive 10x, we would have plus 2. And to get negative 3, we would put that there. So now we have 5x minus 3 equals 0, and x plus 2 equals 0. We're going to add 3 to both sides. We get 5x equals 3. Divide by 5. We get x equals 3/5. And then we subtract 2, and we get x equals negative 2. All right, let's slide over to number 3. This one's just x squared, so our factors are going to be x and x. And we look at the factors of 40. We've got 1 and 40, 2 and 20, 4 and 10, and 5 and 8. So I want to know what numbers multiply up to positive 40 and add to 22. So that'd be 2 and 20. We get x plus 2 equals 0, x plus 20 equals 0. Subtract 2, x equals negative 2. Subtract 20, we get x equals negative 20. All right, number 4. This one we're going to have to factor by grouping. And so this is where we group the first 2 and last 2 terms together. We put those in parentheses, and then we separate with a plus sign. And then we factor out what's in common. So I'm going to take out an x squared here. We're left with 2x plus 3. I'm going to take out a negative 4 in the next one. And we get 2x plus 3. And for all these, we're setting them equal to 0. So then I can pull out that 2x plus 3. And what's left is x squared minus 4. And then I can actually factor x squared minus 4 into x plus 2, x minus 2. All right, so then I set each of those equal to 0. For the first one, I subtract 3. I get 2x equals negative 3. And then I divide by 2, and I get x equals negative 3 over 2. For the next one, I subtract 2, and I get x equals negative 2. and then we add 2, and we get x equals 2. All right, number 5. This one, it looks like we have an x squared that we can take out of each one. We could also factor out a 3, so we're left with 4x squared minus, and then what's 147 divided by 3? That would be 449. So then we can set each of these equal to 0. We can do 3x squared equals 0. And then 4x squared minus 49 equals 0. This one does factor, but it's not quite as obvious, so we'll just solve it this way. So if we divide by 3, we get x squared equals 0, and then we square root. We get x equals 0, and this happens twice, so but because it's 0 twice, we can just write it once. And then we add 49. Oops. We get 4x squared equals 49, and then divide by 4. We get x squared equals 49 over 4. And then when I square root that, both 49 and 4 are perfect squares, and so this would be 7 over 2, positive or negative. So we have 3 unique answers. We've got 0, 7 over 2, and negative 7 over 2. But that 0 technically happens twice, and that's why we, because we have 4, it's a 4th degree polynomial. All right, and then this one's a 3rd degree, so we should have 3 answers. I can pull an x out first. And then if I try factoring this, I know that to get 7, it has to be 1 and 7. Now I just have to figure out for 6x squared, is it going to be 6x and 1x, or is it going to be 2x and 3x? Well, if I put a 2x here, 2x times 7 is 14x, and 3x here, that's going to be 3x. And so if it's negative 14x and positive 3x, that would be 3x minus 7 and 2x plus 1. So then if we set each of these equal to 0, we get x equals 0, that's one of them. We subtract 1, we get 2x equals negative 1. Divide by 2, we get x equals negative a half. Here we add 7, we get 3x equals 7. Divide by 3, we get 7/3. And those are the 3 answers. All right, number 7 through 10. For each of these equations, find the zeros in the vertex. Then graph the function, use algebra, and show all work. So don't just type these into Desmos, you do have to show how we get this using algebra. So the nice thing is with these, it's already factored, so we would do x plus 4 equals 0 and x minus 6 equals 0 since it's already in factored form. So I'm going to subtract 4, I get x equals negative 4, and add 6, and I get x equals 6. All right, so I know that my zeros are going to be negative 4, 0, and 6, 0, which means it's going to cross the x-axis there and there. Yeah. Okay, so that means that my vertex is going to be halfway between there, and the halfway mark is at 1. That's 5 on each side of each 0. So the vertex is going to be 1, comma, and then we have to figure out what the y value is. So to figure out the y value, we just plug 1 in. So it's going to be 1 plus 4 times 1 minus 6. This is going to be 5 times negative 5, which is negative 25. So if I were to graph this, if we did each line was 2, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 would be about like right here. So the minimum would be at 1, negative 25. And I should label some of these, just so that we know that the scale there is going down by 2. All right, next one. The vertex is actually the one that's fairly easy on this one. The vertex is going to be negative 5, 32. And that just comes from both of those. And then the zeros, we just set it equal to 0 and solve. So I'm going to subtract 32 from both sides. I get negative 32 equals negative 2x plus 5 squared. And then divide by negative 2. And I get 16 equals x plus 5 squared. And then I'm going to square root both sides, and I get plus or minus 4 equals x plus 5. So what we do here is we do x plus 5 equals 4, and x plus 5 equals negative 4, and solve both of those. So the first one's going to be negative 1, and then the next one's going to be negative 9. So our zeros are negative 1, 0, negative 9, 0. 2, 3, 4, 5, 6, 7, 8, 9. There we go. And then our vertex is negative 5. And we'll go up by 3s. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. So let's see, 3, 6, 12, 18, just so we can kind of see what the scale is on that. And then let me get rid of some of these tick marks. We don't really need them in here. All right, so our parabola is going to look something like this. All right, let's slide over to the next page and do problems 9 and 10 like. So this one we're going to factor. So I know it's got to be 2x and x, and then we need to multiply to negative 2, so it's going to be negative 2 and plus 1, and that works because that'd be negative 4x, and that would be plus 1x. So our zeros are going to be 2x plus 1 equals 0. We'll solve that. X minus 2 equals 0. When we solve this, we get negative a half. And then when we solve this, we get 2. So negative a half, comma 0. And then 2, comma 0. All right, now to find the vertex, we need to figure out what's halfway between negative a half and 2. And to get that, we do negative a half plus 2 divided by 2. So this would be 1.5 divided by 2, which would be 3/4. Is that right? Yeah. So our vertex is going to be over 3/4. And then we don't know how far up or down it's going to be. But we'll plug it back in. So it'd be 2 times 3/4 is 0.75 squared minus 3 times 0.75 minus 2. And when we plug that in our calculator, we get negative 3.15. 3.125. So our vertex is going to be 0.75, comma, negative 3.125. So if I go over here, negative 3.125 is about right there, so our graph's going to look something like this. All right, number 10. So this one, I don't think it factors, because we really only have a couple choices here. It's going to be 3x and x, and then to multiply up to negative 3, it's either going to be plus 3 minus 1, which would give us minus 3x plus 3x. That doesn't work. Or, you know, if we switch them around, if we did minus 3 plus 1, it's the same problem. That's not going to work. But then if I switched the numbers around, it's still not going to work, because we'd have 9x and 1x, and that's not going to give us 2x. So what we have to do here is the quadratic formula. So there's different ways to solve these. One of them's factoring, one of them's quadratic formula. They all get you the same answer. But this one, since it's not factorable, you have to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so negative b is negative 2. B squared would be 2 squared minus 4 times a, which is 3, and then times c, which is negative 3, all over 2 times a, and a is 3. So negative 2 plus or minus the square root of 4 plus 4 times 3 is 12. 12 times 3 is 36, so 4 plus 36 all over 6. So we get negative 2 plus or minus the square root of 40 over 6. All right, so this would be our exact answers. But that doesn't really help us on the graph. So I'm going to plug those into my calculator. And when I do that, I get x is approximately equal to what? And all I'm doing is I'm just plugging negative 2 plus square root of 40, and then divide that by 6, and then negative 2 minus square root of 40, hit enter, and then divide that by 6. So type that in my calculator, and here's what I get. 0.72 and negative 1.39. So it's about 0.72 comma 0 and negative 1.39 comma 0. So if I put those on the graph, 0.72 is about right there, negative 1.39 is about right there. And then to find the vertex, we're going to add those up and divide by 2. And that's going to give us the approximate value of the vertex, so 0.79 plus, I wrote that wrong, didn't I? It's 0.72. And then, man, I totally messed this up. So back up the boat here. The right idea, I just totally wrote the numbers down wrong. 0.72 plus negative 1.39. Divide that by 2. There we go. Negative 1.39. And then divided by 2 is negative 0.3 for our x value. And so negative 0.3 is about right here. That's going to be where our vertex is located. And then we just put negative 0.3 into the original equation. So it'd be 3 times negative 0.3 squared plus 2 times negative 0.3 and then minus 3. And when I plug this into my calculator, I get negative 3.33. A lot of 3's going on here. So if I graph this, negative 0.3 and then down 3.33, so about there. So yeah, the numbers were a little more ugly on this one, but it's the same idea. You find the zeros by doing quadratic formula, and then find the average of those, and that'll give you the x portion of the vertex, and then plug it in to get the y portion. Okay, the hard part, the heavy lifting of this assignment is done. Now we just got a few multiple choices and stuff like that. Okay, each of the following polynomials is represented by a graph on the right. Match the polynomial with the correct graph. So the whole idea of this one is to identify what type of polynomial it is. And since this is a fourth degree, it's going to have a W shape. And it's positive. If it was negative, it'd be flipped upside down. So that's going to be graph B, this one. Okay, number 12 is an x to the third equation. That's the highest exponent. And normal x to the thirds looks something like this. However, this is negative x to the third, so it's going to be flipped upside down. So it's going to look something more like that. So that's going to be D. It starts in the upper left and ends in the lower right. This 13 is a positive x to the third, so it's going to look something like that, which would be A. And then process of elimination should give you the next one, but since it's a sixth degree and it's negative, that means it's going to be upside down, and it's going to kind of look like an M with an extra hump in the middle, so that would be C. All right, so that is page 2. Let's flip to page 3 and finish these. So 15 and 16 are using the quadratic formula, and then finding out where do they cross the x-axis for number 17. So let's use it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And let's plug stuff in. So negative 8 would be positive 8 plus or minus the square root of negative 8 squared minus 4 times a times c all over 2 times a. All right, so we get x equals plus or minus negative 8 squared is 64 minus 4 times 2 is 8, and 8 times 10 is 80, and 2 times 2 is 4, so we get x equals 8 plus or minus 64 minus 80 is negative 16 over 4, and then the square root of negative 16, well, the square root of 16 is 4, and so the square root of negative 16 is 4i. So this can be simplified. All of these numbers are divisible by 4, so this would be x equals 2 plus or minus 1i over 1, or you could just write it as 2 plus or minus I. So that would be the exact answers for this one. And then there's really no square root, and so that's also the rounded answer. And it seems a little weird, but there is, you know how there's normally like an XY graphing plane? There's also one that deals with imaginary numbers, but we're just not going to get into that. So the exact and the rounded here are the same because there's no square root. Okay. Number 16, I'll write down the formula again. negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 4 all over 2a. So negative 3 plus or minus the square root of 9, and then 4 times 2 is 8. 8 times 4 is 32, so 9 plus 32 all over 2 times a, and a was 2. I forgot to put that in there, so that's 4. So this would be negative 3 plus or minus the square root of 41 all over 4. So that's going to be our exact answer. Negative 3 plus or minus the square root of 41 over 4. So then for the rounded answers, we're going to do negative 3 plus the square root of 41 over 4, and that is approximately something. I'll type that in. And then negative 3 minus the square root of 41 over 4, and that is approximately something else. Let me type those in now. And I get, let's see, 0.85 and negative 2.35. So those are my two approximate rounded answers. All right. Number 17 asks, where do the previous two problems cross the x-axis? Well, on number 15, since we have imaginary answers, it doesn't. So that means that your parabola is going to be either floating up above the x-axis or below. Number 16, well, that's what our answers are. So at approximately 0.85 and negative 2.35. Just want to make sure you know that connection, that the answers are where it crosses the x-axis. And then the last two. It's a word problem, but it's not asking you to solve it. It's just asking you to identify which equation would represent the correct one. So it says the path of a projectile being shot out of a cannon follows the equation y equals negative 16x squared plus 176x plus 7, where x represents the time in seconds after the projectile was shot, and y represents the height in feet of the projectile in the air. So part A says, which equation would represent the height of the projectile after 5 seconds? Well, it says in the original question, x represents the time in seconds, so we're just looking for when is x equal to 5, and that would be B. Because if you notice, they just replaced the x's in the original equation with 5s. That's all they did. That's how I know that. Okay, question B, which equation would represent the time it would take for the projectile to reach 5 feet above the ground? So 5 feet above the ground, this is going to be the y value. So we are looking at question A because we're putting 5 in for y. And now on the first one, that's pretty easy. You just punch that into your calculator. So this one isn't too bad. If you're solving for this problem, I know it doesn't say to solve, but if you were, then what you would do is you would set it equal to 0. So if we had 5 equals negative 16x squared plus 176x plus 7, then I would start by subtracting 5 from both sides, and I get 0 equals negative 16x squared plus 176x plus 2, and then I would solve that. And I would either use the quadratic formula, or I could graph it, or I could see if it factors, which I don't think it does. So, all right, so that is it. That is the answer key for the Day 14 review.